Good day. Our topic for this video is all about conic sections. Conic sections includes degenerate conics, ellipse, circle, hyperbola, and parabola. So parabola is the set of all points in a plane equidistant from a fixed point and a fixed line. So if the cutting plane is parallel to one and only one generator, the curve is parabola. In this illustration, this refers to the generator of the cone. Actually, that the upper and the lower portion of the cone, or the cones rather, has two generators. So, and this shaded area here represents the cutting plane. So, if the cutting plane is only parallel to one generator of the cone, the curved form is parabola. And also, we have ellipse. Ellipse is the set of points in a plane, the sum of whose distances from two fixed points is constant. So if the cutting plane is not parallel to any generator, the curve is ellipse. So from this illustration, we can see here that the plane is not parallel to any of these two generators because it intersects the two generators of the lower cone. That's why the curve formed here is ellipse. However, if the cutting plane is not parallel to any generator but is perpendicular to the axis, the ellipse becomes circle. So we can notice here that the cutting plane is not parallel to these two generators. However, we can see that they form a perpendicular relationship. And if the two intersecting lines or objects forms a perpendicular relationship, they form a 90-degree angle. Therefore, the curved form here is the special type of ellipse, which is circle. Next, we have hyperbola. Hyperbola is the set of all points in a plane, the absolute value of the difference of whose distances from two fixed points is constant. And these two fixed points are called the foci. So if the cutting plane is parallel to two generators, the curve is hyperbola. Simple as that. So next, we have point, line, and two intersecting lines. So this point line and two intersecting lines represents the concepts of degenerate conics. Later on our discussion, we will discuss a deeper concept of this. However, on this video, we will just focus on the special type of ellipse, which is circle. Okay, so what is circle? So circle is a set of all points that are coplanar, such that the distance from a fixed point is constant. When we say coplanar, these are points that are found on one plane only. However, if it is linear or linear points, these are points found on one line only. But here, circle is the set of all coplanar points such that the distance from a fixed point is constant. So we are talking about the points found on one plane only. Okay, so when we talk about circles, we probably might encounter two equations regarding circles. First, we have this x squared plus y squared that is equal to r squared. And second, we have quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. The first equation represents to the standard form of the equation of the circle, wherein the center is located at the origin. And the next one, or the second one, is also a standard form of the equation of the circle, where the center is located on point HK. So there is now a translation of axis, or the graph. The center of the graph is not located at the center. So we have here two illustrations. The first illustration represents the circle or the graph of the circle with the equation x squared plus y squared is equal to r squared, wherein the center is located at the origin. So we have here c is equal to 0, 0. And this line here from the center going to the side of the circle represents the radius. But if we're going to extend this one from here going to the other end of the circle, it represents the diameter of the circle. So if the given value in your problem later is equal to the diameter, all you need to do is to divide the diameter into 2 in order for you to get the radius or the value for the radius. So here we have point P that has the value of x and y. So we will just substitute this one here to find the answer later depending on what is being asked on the problem. Remember, this is the graph for x squared plus y squared is equal to r squared, wherein the center is located at the origin. Next one, we have for the graph of the equation quantity of x minus h squared plus quantity of y minus k squared, that is equal to r squared. So we have here the center is not anymore located at the origin, but it translated into the other part of the Cartesian coordinate system. Specifically, it is located on the quadrant 1. So we have here the center is on the point HK. We have the radius and the point P, which has x and y. And also, we will have some example of this later. So we're going to find the equation of the circle given the center and the radius. Okay, so now we have these examples. We have to determine the standard form of equation of the circle given its center and radius. Afterwards, we will find or we will going to draw its graph. So for the first example, we have center that is located at the origin, or the value of h and k is equal to 0, 0, and the radius is equal to 5 or 5 units. Next one, the center is located at h and k, which is negative 2 and 7, and radius is equal to 4 units. So first we will solve for the first example or first problem, wherein we have the center that is located at the origin. Okay, so now we have now the solution of the given that has the center of 0, 0 and radius that is equal to 5 units. So I showed you here two ways of solving the equation of the circle, wherein the center is equal to 0, 0 and radius is equal to 5. So first, we have x squared plus y squared is equal to r squared. Actually, if the given condition gave you the center that is equal to the origin or 0, 0, you can actually apply this directly, this x squared plus y squared that is equal to r squared. All you need to do is to substitute the value of radius to your r squared. Don't forget, class, or don't forget that 2 is the exponent of the radius. It doesn't mean that r squared is equal to 5. It means that radius 5 or the value of radius that is equal to 5 should be squared to find the value of r squared here. So we have x squared plus y squared is equal to 5 raised to 2. So x squared plus y squared is equal to 25. Or in some other way, we can apply this equation You can also apply this equation. You will just need to substitute the value of h and k, and also the radius. So going back here, we have quantity of x minus h squared plus quantity of y minus h squared is equal to r squared. We will just substitute the value of the h and k. So here we have h and k here is equal to 0, 0. So moving on, we're going to substitute 0 for h and another 0 for k. Sorry, it should be k. So we have here x minus 0, or quantity of x minus 0 squared plus quantity of y minus 0 squared is equal to the value of radius 5, that is squared. So we have x minus 0 is x raised to 2, plus y minus 0 is y, and y raised to 2. And also 5 squared is equal to 25. So you can make use of both ways or both method. But always remember to be careful with the signs, because most of the time students will have a wrong move dealing with signs of numbers. Okay, here I will show you how I am going to solve problem number 2 using the equation or the formula x, or quantity of x minus h squared plus y minus k squared, that is equal to r squared. So we will just substitute the values of h and k from the given to the equation and also the radius. So we have here x minus h here is equal to -2, so we will just substitute -2. Take note, we have here negative, and also the operation here is minus. So we will have, we need to enclose the value of h by a parenthesis to avoid confusion of signs. So we have -2, another close parenthesis. So we have 2 open parentheses. Make sure that the close parenthesis should be also equal to 2. So here, and raise it by 2, plus, and next open parenthesis, y minus the value of k. We have positive, so no need to enclose it with close and open parenthesis. So we will just write this directly and square the y minus 7, and is equal to the value of radius is 4 raised to 2. So we have to simplify this equation from left to right. So we have x. So negative times negative, here we have positive 2 squared plus y minus 7 squared is equal to 4 raised to 2. We have 4 times 4. So this is 16. So we have now the standard equation of the given that is not located of a given which has a center that is not located on the origin, but rather at h and k, and the radius that is equal to 4 units. So we have quantity of x plus 2 squared plus quantity of y minus 7 squared, that is equal to 16. And later on, we will try to graph these two problems here. We have number 1 and number 2. And now we're going to graph the first example, which has the center that is located at the origin and the radius that is equal to 5 units. First, we need to construct our Cartesian coordinate system with x and y axis. So we have to plot the graph by locating the center and the radius. So in plotting the graph, we have to locate first the center of the circle. Since the center of the circle here is at the origin, we just need to plot its point. Next, from the center, we have to count 5 units going to right, upward, going to left, and going down. So we have 1, 2, 3, 4, 5, and locate the point. Next, 1, 2, 3, 4, 5. Going to the left, 1, 2, 3, 4, 5. Going downward, 1, 2, 3, 4, 5. Afterwards, we have to connect the dots in our Cartesian coordinate system. Just make sure that it looks like a circle and not square. So we have to connect the dots. I'm going to trace this and make this circle later. So we have now the circle, the graph for example number 1. It may not look like a perfect circle, but it's the graph of example number 1 with the center that is located at the center, at the origin rather, and the radius that is equal to 5 units. So for the graph of number 2 example, we have to locate first the center, which is located at the point -2 and 7. So we have here for the x-intercept, we have -2, and for y-intercept, we have 7. So we have to count 7 units going up since it is positive. So we have 1, 2, 3, 4, 5, 6, and 7. So this is the center of the circle. It is located on this point. So we have to locate the point first. After that, since we have the radius that is equal to 4 units, so from the center we have to count 4 units going to the right, going up, going down, and going to the left. So we have here 1, 2, 3, 4. That is with respect to our x-axis. So going to the left, we have 1, 2, 3, 4. So here it is. Next, for the y-axis, we have going up 4 units, 1, 2, 3, 4. And going down, 1, 2, 3, and 4. Next, we have to connect the dots to form the graph of the circle. Make sure that it looks like a circle and not a square or rectangle. Here it is. This is the graph of the circle with a center located at point -2 and 7, and with the radius that is equal to 4 units. What if you have this kind of given, wherein the center is located at the point square root of 5 and 2 square root of 2, with a radius that is equal to square root of 10 units? How are you going to solve this problem involving radical numbers? So simple as this, all we need to do is just use these values in our formula in the format of x, or quantity of x minus h squared plus y minus k squared is equal to radius squared. Here we have to find the standard form of the equation of the circle by using this given. So we're going to substitute the values. We have quantity of x minus square root of 5 squared plus y minus 2 square root of 2 squared is equal to radius is equal to square root of 10 raised to 2. Next, we have to simplify this second degree process. So we have quantity of x minus square root of 5 squared plus the quantity of y minus 2 square root of 2 squared. And here we have to cancel this out since the index here is equal to the exponent 2. So we can cancel this out here. Or in some other ways, we can make use of this process since square root of 10 raised to 2 is also equal to the square root of 10 raised to 2. So we have square root of 10 raised to 2 is 100. And square root of 100 is 10. So, magkapareha lang sila. Therefore, the standard form of the equation of this circle is equal to the quantity of x minus square root of 5 squared plus y minus 2 square root of 2 squared is equal to 10. How are you going to find or to plot the graph? All you need to do is to make use of calculator. How to find or how to plot square root of 5, how to plot 2 square root of 2, and how to plot square root of 10. So using calculator, you just need to input square root of 5, and whatever value will be given to you by the calculator, you just need to do estimation in the plotting of points in the Cartesian coordinate system, and after that, you can plot the graph of the circle.